Have you ever, say, filled up your car at the pump, or maybe seen some high-precision machine working and just stopped to think, how do we actually know those measurements are accurate?
Right. We just trust them, don't we?
We do, but behind that trust, there's this whole complex, mostly hidden world of absolute precision. That's the world of calibration laboratories.
Yeah, these are the sort of unsung heroes, making sure everything from, the fuel going into your tank to maybe a critical part for an airplane is measured exactly right. Spot on.
It's an incredible level of detail,
Um,
and it's definitely not an accident.
No, not at all. It's built on, well, really rigorous standards, constant checking, and meticulous oversight. And today, we're kind of pulling back the curtain, taking you on a deep dive right into how one of these labs works.
We're looking at it through the lens of a pretty tough quality audit.
Exactly.
Our main source document for this deep dive is this fascinating ISO IEC 14025.2017 audit simulation case study. And this wasn't just theoretical.
No, it was a real-world internal audit simulation done for a company called Perfect Calibration, LLC.
All right, Perfect Calibration LLC. They're a pretty big player, based in Dubai, UAE, a place where precision really matters. They've got, what, over 200 employees?
Yeah, 211 people. And this specific audit simulation happened back on July 15th, 2025.
So for you listening, getting under the hood of this internal audit process really gives you one of those aha moments.
Yeah. It shines a light on these systems that we usually don't see, the ones that ensure accuracy and trust in almost every industry you can think of.
Food, medical devices.
You name it. And we're not just going to list what they found. We're going to dig into why it matters, what it tells us about this constant chase for, well, perfection.
Okay, let's put on our investigator hats then. Let's set the stage. When we talk about this kind of audit, it's all about compliance with ISO IEC 14025.2017. Now, people in quality control know this one well.
Oh, yeah, it's the benchmark.
But for everyone else, what does that standard, actually require a lab to do?
Well, in simple terms, it lays out the requirements for a lab to prove it's competent, that it's impartial, and crucially, that it consistently produces valid, trustworthy results.
So it's like the ultimate quality rule book.
Pretty much. It ensures that when a lab gives you a calibration certificate, you can actually rely on it, have confidence in what it says.
And who is checking perfect calibration against this standard?
The audit team was led by Asha Khan. Then there was Saeed Al-Mansouri as the technical auditor and Fatima Rahman observing the process.
And it sounds like they didn't just look at one small corner of the lab.
No, definitely not. It was comprehensive. The scope covered a whole range of their work: electrical calibration, temperature and pressure, dimensional metrology that's measuring physical dimensions, and also mass and volume calibration.
So tiny measurements up to big weights.
Exactly. They were looking across the board.
And their goals were clear, right? Check conformity, see if procedures were actually being followed.
Yeah, evaluate technical competence, impartiality, which is key, and maybe most importantly, find areas where they could improve.
Okay, so after all that digging, what was the headline, the overall verdict?
The final conclusion was that Perfect Calibration LLC was found partially compliant with ISO IE 17025.2017. But, and this is important, they noted key technical gaps that require immediate attention.
Ah, okay, so partially compliant.
Oh.
That straight away tells you we're looking at a mix, some things done well, but also some serious challenges.
Exactly. It sets the scene perfectly.
And partially compliant does mean they were doing some things right. It's probably good to acknowledge that before we get into the problems. Where did Perfect Calibration actually shine? What were their strengths, according to this audit?
Yeah, absolutely. They showed strong compliance in several really fundamental areas, things you need for any decent quality system.
Like what?
Well, for instance, their management regularly conducts management reviews. That shows commitment right from the top. That's clause 8.9 for those following the standard.
Okay, good sign.
And they also consistently schedule and run their own internal audits, clause 8.8. So they're committed to checking themselves and improving.
And what about the actual measurements, the core of what they do?
This is huge. Their equipment calibration is traceable back to the Emirates Metrology Institute. That's their national standards body.
Right, that's clause 6.5.
Yeah.
And that traceability is critical, isn't it? It means their own master instruments are verified against the national standard.
Precisely. It establishes that reliable chain of measurement accuracy. It removes doubt about their fundamental baseline. Really important.
Okay. Anything else on the positive side?
Yeah, they also had an effective system for handling customer complaints. Clause 7.9 shows they listen and have a process to fix things if customers aren't happy.
So these compliant areas, they're not just, ticking boxes. They show a real foundation.
Absolutely. They demonstrate that perfect calibration does have a fundamental commitment to quality management. It provides that necessary base to build on.
But, as we heard, only partially compliant. So let's pivot now. Let's talk about the issues, the nonconformities the auditors found. For listeners maybe less familiar with audit speak, what exactly is a nonconformity, or NCR, here?
Sure. An NCR, a nonconformity, is simply a failure to meet a specific requirement of the standard, like ISO 17025 in this case.
And they can be minor things, or quite serious.
Exactly. They range from, say, small paperwork errors to really major technical gaps that could potentially compromise the validity of the lab's results.
Imperfect calibration had some major ones flagged. The first big challenge, NCR1, was surprisingly fundamental, yet absolutely critical, making sure their people were demonstrably competent. What did they find there?
Okay, so they found a technician, Mr. Zaid, who was doing pressure calibration. The issue was he lacked documented competence assessment for the specific method he was using.
Documented competence, so not necessarily that he didn't know how.
Right. The evidence showed there were no records of him completing, say, a practical hands-on assessment for that specific method, or getting formal approval from the technical manager for that method.
So it's like, you might be a great driver, but if you don't have the specific license for driving a heavy truck, you can't legally drive it.
Oh.
Here, the license was missing on paper.
That's a good analogy. In a high-stakes environment like calibration, where people rely on your results for safety or quality, you absolutely need that documented proof. You can't just assume competence.
Makes sense. And the required action was clear. Document the competence, including the practical skills, for all personnel, for all methods they perform.
Precisely. It highlights the rigor needed.
Yep.
Okay, moving to NCR 3. This was another major, and a really significant one. It was about method selection and validation. Clause 7.2.1.1.
Method validation. Checking that the way you do something actually works reliably.
Exactly. They found that the lab was using a non-standard calibration method for a torque wrench. But here's the kicker. It was used without proper validation.
Ooh. Okay. What did that mean in practice?
It meant there was no method validation file showing they'd tested the method, no evaluation of the measurement uncertainty associated with it, and critically, no record of customer approval to use this unproven method.
Wow. That feels like a pretty big deal. Using an unproven method seems like it could lead directly to inaccurate results.
It absolutely could. It fundamentally undermines the trust in the calibration certificate. If the method isn't validated, how can you be sure the result is correct? This was major, like you said, and the action was clear. Stop using it, validate it properly, figure out the uncertainty, then maybe use it again.
Right. Okay, another major one was NCR 5. This related to measurement uncertainty. Explain that a bit.
Okay, measurement uncertainty, clause 7.6. Think of it like this. No measurement is perfectly exact. There's always a small margin of doubt or error.
It's like a plus or minus value.
Exactly. Labs have to calculate this uncertainty for their measurements to show how precise they really are. It's a statement of quality. The auditors found that perfect calibration's uncertainty calculations, their uncertainty budgets for humidity calibrations, hadn't been updated.
Updated after what?
After a recent change they'd made to the environmental controls in the lab, their calculations were still based on the old environmental conditions.
So the temperature or humidity stability might have changed, but their uncertainty claims hadn't caught up.
Precisely. The uncertainty files they were using had outdated values for things like environmental variance.
That seems subtle, but potentially quite important. If the environment changed, the uncertainty probably changed too.
It likely did. And it underscores how dynamic calibration needs to be. You can't just calculate uncertainty once and forget it. You have to maintain it, especially if conditions change. The action. Recalculate the uncertainty with the new data and revise any reports that might have been affected.
Okay, so those were the majors,
Yeah.
serious stuff.
Yeah.
But there were also minor nonconformities, right? Often about process or documentation.
Yes, a couple of those. NCR2, for example, dealt with equipment maintenance clause 6.4.4. They found that a specific calibration oven, hashtag OC112, hadn't had any preventive maintenance recorded since January 2024.
And was it due?
Well, the manufacturer recommended monthly checks, but the maintenance logbook was just missing entries for several months.
Okay, seems like a slip-up. Minor, but you can see how that could lead to bigger problems down the line if the oven starts drifting.
Exactly. Equipment reliability is key. The action was straightforward. Update the log, do the missed maintenance, and put some kind of alert system in place so it doesn't happen again.
Right. And the other minor one, NCR 4.
NCR 4 was about technical records under Clause 7.5. The auditors looked at some calibration reports. They listed 3 specific IDs. #CAL5843, #CAL5861, #CAL5865.
Yeah, the issue.
The field identifying who reviewed the final result? It was blank. There is no signature or identifier for the final reviewer.
Ah, the final check. So accountability and the audit trail were broken there.
Correct. Every critical step needs to be traceable back to who performed it and who checked it. This was minor, but still important for record integrity.
And interestingly, the report notes this one was already closed by the time the summary came out.
Yes, that shows they reacted quickly to fix that particular procedural gap once it was pointed out, which is a positive sign in itself.
Definitely. So beyond the actual rule-breaking nonconformities, the auditors also made some observations. What are those?
Observations are different. They aren't direct violations of the standard, but they're areas of concern or potential risk. Or maybe just opportunities for improvement, ways the lab could do even better. Proactive stuff.
Got it. Let's look at OBS 1. This one was about impartiality, Clause 4.1. This sounds interesting touches on the human side.
It does. During interviews with staff, one of the technicians mentioned feeling some pressure from the sales team.
Pressured to do what?
To expedite urgent calibrations, to push things through faster, maybe cutting corners implicitly because of commercial demands.
And did they find evidence that it actually affected results?
No, the auditors were careful to note it hadn't yet affected results, but they flagged it as a future risk.
Because that kind of pressure, even if subtle, can really undermine the whole point of impartial, objective measurement.
Absolutely. It introduces a potential conflict of interest. Quality and technical integrity should always come before sales targets in a calibration lab. It's a culture thing that needs watching.
Crucial point. Okay, OBS 2 is about environmental conditions, Clause 6.3.
Yeah, this links back to that uncertainty issue, actually. The auditors looked at the temperature log for one of the calibration rooms. It showed occasional temperature readings that went slightly outside the acceptable range. The target was 23 degrees C, 2 degrees C, and sometimes it drifted beyond that.
Even small drifts can matter for high-precision work, right?
They really can, especially over time. So the recommendation wasn't an NCR, but an observation. Consider putting in an automated alert system to warn staff immediately if the temperature starts to go out of spec.
Makes sense. Be proactive. What about the last one, OBS 3? Validity of results, Clause 7.7.
Right. So perfect calibration was already doing some internal quality checks. Things like taking a measurement, again, blind, just to see if they get the same result, blind recalibrations.
That sounds good. So what was the observation?
The observation was that while they were doing these checks, they weren't systematically analyzing the results, statistically analyzing them, that is.
Ah, so they weren't looking for trends or patterns in the check results over time.
Exactly. The recommendation was to implement something like trend analysis or control charts. It's not just about doing checks, it's about learning from that data. Are things slowly drifting? Is one method less consistent than another?
So using the quality check data to get smarter and maybe catch problems before they become serious.
Precisely. It's about proactive quality assurance, not just reactive checking.
Okay, so summing up the situation. Perfect Calibration has this audit report, a mix of good practices, some minor slips, and these 3 major nonconformities that really need fixing. What's the path forward for them?
Well, the report mentions a corrective action plan is in place for each NCR. It outlines who's responsible, the deadlines, and the current status.
Right, we saw NCR 1 on competence was in progress, NCR 2 on maintenance was still open, but NCR 4 on records is already closed.
Exactly. And beyond just fixing the specific NCRs, the audit team also gave some broader strategic recommendations.
Like what?
Things like maintain regular competence reviews, especially when people are new or methods change, really embedding that culture of documented competence.
Reinforcing NCR 1.
Yep. Also setting up automated reminders for calibration and maintenance to avoid things like that missed oven check in NCR 2.
Makes sense. Use technology.
And crucially, strengthen those method validation procedures. Do it before using new methods on customer jobs, not after the fact. Address NCR 3 head-on.
Get it right from the start.
And finally, leverage data analytics for internal QC. Turn those checks into real insights, as suggested by OBS 3.
Okay. So what's the immediate next step required by the auditors?
The clear conclusion was that because of the major NCRs, a follow-up audit is needed, recommended within 60 days,
To verify closure.
to verify that those major nonconformities have been effectively addressed and closed out. It's not punitive, it's part of the process to ensure they really are back on track and meeting the standard fully.
Right. So this whole deep dive into just one audit at Perfect Calibration LLC, what does it really tell us, and why should someone listening care?
I think it vividly highlights this incredibly complex, delicate dance that goes on inside these labs.
Dance between what?
Between having documented procedures, ensuring your people are truly competent and you can prove it, and controlling every little variable like the environment, all to ensure the accuracy of measurements we just take for granted every day.
It really shows that balance between, demonstrating what you're already doing right and then facing up to and fixing the critical areas that need urgent work.
Exactly. It's a continuous process, and connecting it to the bigger picture for everyone listening.
Yeah.
It really makes you think, doesn't it?
How so?
Well, in a world that relies more and more on precise data, think self-driving cars, medical tech, climate science, everything, what other hidden audits or standards are operating quietly in the background?
Ensuring the quality or safety of things we use constantly.
Yeah.
Oh.
And maybe the more provocative thought is, what might be the unseen nonconformities, the hidden risks or gaps bubbling just beneath the surface in those systems too?